So we are going to do some rules today, and these are rules that apply to integrals. And yesterday, when we did the areas, I kind of hinted at some of these. So we did like an area of one triangle plus an area of another triangle equals the total area. And I discussed how the integral goes from A to B. This top value needs to match the bottom value of an integral to be subtracting them from each other. So that's the similarity aspect. So A goes to B goes to A if you put a negative in front of it. So a negative would reflect it. So if the area is going from A to B, by making it a negative, you've reflected it down so it's B to A. That is the order of integration property. The zero property, which I don't know why, but everybody forgets. When we take our quiz next week, I will ask a question like this. It'll be like the integral from 5 to 5 of x dx, and somebody will try to tell me it's equal to a number other than 0.
Isn't that like saying what's the area between this and these two? Like this one.
If you do the whole, you're getting
Just saying, it happens. Okay, this should make sense if you think about the area of a rectangle because it has a 0 width. So all you have is the height of x, and the width is 0.
Oh wait, that's period.
All right, a constant. So a to b of k f of x dx is the same as factoring out the k. So let's say you have a quadratic function, everything's divisible by 2. You can bring that 2 out in front and then kind of multiply it in at the end.
So, like, is the order, like, for instance, like A and B on top, would it be A minus B, or is it B minus A?
B minus A.
That's always upper minus lower.
Good? Okay, we have a sum and difference rule. So the sum and difference essentially says if I want to add two functions together, it's the sum of one area plus the sum of the other, or you can subtract them.
Is it like the same rules for derivatives, essentially?
Yes.
So you can do it on the inside of the integral?
Yes. So again, what this does is allows us to integrate functions that are added or subtracted separately.
That's easier than derivative.
It is.
This is kind of like the addition to, or I mean the multiplication to derivative addition. Do it like this, versus where you can do something divided.
Okay. Additivity. So this is another important one. So what it says is that you can add two integrals together for the same function as long as they continue from each other. So we do that when we look at two functions with two geometric shapes, and maybe you have one triangle and another triangle. So what you're doing is you're taking triangle A and adding it to triangle B. So they have to start and end at the same spot. So it goes A to B. So this one ends at B. The next one has to start at B. So that's like finding the total area from A to C. So the B's in the middle sort of cancel each other out, even though we're adding them together separately.
That's only when they're the same function, right?
Mm-hmm. So you have to pay close attention to the limits of integration. This comes in handy when dealing with total area or other functions where we need to break them into smaller parts. Good? So what we're going to do is we are now going to be given functions. We have no idea what their graphs look like. We have no idea what the functions are, but we know values of the function. We can apply these rules to come up with answers. So we have two given statements. We are given the area of f of x dx is equal to 10 from 2 to 6. We're also given from 2 to 6 that g of x dx is equal to negative 2. So we know two different functions, values, for two different times. So it asks, what is the sum of those two integrals from 2 to 6? So essentially what you're doing is you are integrating these as two separate pieces. So you're saying, all right, 10 plus negative 2 is 8. We can apply the subtraction property. So now we're taking 2 to 6 of g of x dx and subtracting 2 to 6 of f of x dx. Anytime you write an integral, you must include the dx after the function. The dx is the variable of integration. If it's not there, then essentially you're integrating with respect to no variable. So you can't take the area of a rectangle without the width of the base. You can't integrate without the dx. So g of x is negative 2. F of x is positive 10. So negative 2 minus 10 makes the integral negative 12. Letter C is a representation of the constant rule. So it's as if you're multiplying a function by 3. We can think of that 3 as being brought in front of the integral. This is one of the most useful rules that we're going to review from today. I use this one all the time. Factoring out a constant makes multiplication so much easier. So we're going to factor out that constant of 3. So now this becomes 3 times 10 or 30. Okay? Example D. So again, we have a summation of two parts. So what we're looking at is the integral from 2 to 6 of f of x dx plus the integral of 2 to 6 of 2 dx. So we were given f of x dx from 2 to 6 is 10. What do you know about an integral of 2? Well, 2 is what type of function? Constant. So we know how to use area to integrate an integral. So if it's a constant, exactly, you take the difference between the two bounds. So 6 to 2 is 4. And then a height of 2. So that means the area of this rectangle would be 4 times 2, or 8. So the area plus the integral we were given is 18. Good? Let's look at a second example. So now we're given two different statements. We're given f of x dx is 10 from 0 to 5. And we're given f of x dx is 3 from 5 to 7. What would the integral of f of x look like from 0 to 7? So what we need to do is we need to take 0 to 5 of f of x dx. But we don't have 0 to 7, so we have to take 0 to 5 and add it to 5 to 7. It just like
well, because your pants off.
what a bad problem now.
Ah! Fucking stop spawning.
Done broke.
Oh, Started running again. Wow. You got lucky. That never happened. Computers never fix it. They always do.
All right, so we have f of x dx,
Who?
and then we have 5 to 7 of f of x dx. So that's 10 plus 3, or 13.
Maybe it's easy. He needs at least a 2-week notice. He needs at least a 2-week notice before you do.
Okay, the integral from 5 to 0 of f of x dx.
What? I'm so confused.
That's just for the appraisal.
That's just
Huh?
that's just
Oh, you do all.
able to come around.
Alright.
After 2 weeks. Yeah, I should be able to come down.
How do you do 5 to 0?
You have to do
Oh,
negative.
Yeah, we need to use the negative property. So this is negative 0 to 5. So that means this is negative 10.
I think that's what y'all
Okay, what do we do about letter C?
0.
There we go.
We were all waiting.
I know, you're all so excited for my example. Alright, and then 0 to 5, where you have 3 f of x.
John's 10, so make that number 30.
The only thing is making these squiggly things takes me a lot of time.
Oh. It's like an S. Just make it an S.
I've just been doing
Reading
really
derivatives, and we're like, oh, this is so pretty. And then you get
It's a long
Right.
Alright,
Doesn't need to
how about example 3?
And there it is.
Oh,
No.
So it says, suppose that h is continuous. So we go from negative 1 to 1, and we get that h of our dr is 0. And we have negative 1 to 3 of h of r dr is 6. How do I find 1 to 3?
Good question.
So what you need to do is come up with a way to manipulate what you have to give you what you need. So you need your beginning and ends to be 1 and 3. So we need a 1 here, and we need a 3 there. How can I manipulate what I have to get me that?
3 over negative 1 minus 1.
I got this.
Oh, wait, let me see.
Backwards.
Flip the 1 over negative 1, like you said,
Yeah, so you're going to flip this one.
and then it becomes.
So by making that a negative, it becomes 1 to negative 1. Now I have a negative 1 up here, so I need a negative 1 down there, which was given to me here.
The second one needs to be negative.
This one? No,
Oh, wait, it's
because it's the original.
Yeah.
So only the first one's negative, so it's like negative 0 plus 6, which is 6. All right, I want negative 3 to 1. So what did I find here? I found 1 to 3, right? So how do I flip this? What do I have to do to this? Make a negative.
So this one.
So I need like a negative, negative. Yep. All right. So a negative negative makes it a 6.
Then that's really weird.
Yep.
I don't like that one. Yeah. Can we go back?